Hi, and welcome to our first episode in the 3D printing series. So just a few housekeeping rules. Can we make sure we're all on mute? We have a chat function. If you want to ask any questions, please use the question box. So I'm Jordan Strachan, the CAD technician here and at the Aura Innovation Center. And today we'll be hearing from Dr. Ellis Marshall about 3D printing with plastics. So we are the Aura Innovation Center. We're a home of low carbon innovation, and we're based in Humber. So I'll now pass on to Dr. Ellis Marshall.
Brilliant. Right. Okay. Thank you very much for joining us here at the Aura Innovation Center and for joining us in InventX. So today is going to be a bit different. We're going to be talking over this video that we've got here. So it'll just be me on the side in this video, and we'll be pausing at moments to do polls and to answer any questions. So again, if you've got any questions, please ask them in the Q&A, and there's the chat function as well if you want to speak to the rest of the crowd here. So thank you very much. We're going to be talking about 3D printing with plastics. This first one, we're going to be looking at fused deposition modeling and other types of 3D printing with plastics. So I will mention FDM, which is this fused deposition modeling, and I'll explain it in a minute. But it's a very common type of 3D printing that happens all over the country, all over the world. Many students have 3D printers in their bedrooms, just creating designs overnight. Many people have them in their businesses, or they have them in their offices. So without further ado, this is us. So we do a lot of work with plastics. These are plastics. These are shredded and filament plastics. These are called thermoplastics. This type of plastic we're using here is called PLA, which is polylactic acid. It's a very, very common, it's the most common 3D printed plastic you will work with. It's commonly available from cornstarch, it's sustainable, and it can be compostable in the right circumstances. So it's a very widely used plastic. And here we are using it on one of our Ultimaker printers here at the Aura Innovation Center in our 3D printing zone of InventX. And we do use a lot of plastic, and we'll get onto that later about what we do with our waste and our whole circular economy. So I just want to pause here for a second and talk about FDM, so this fused deposition modeling. So this is where your plastic comes into the 3D printer, nice and cold, so you can handle it. It gets heated up to about 150 degrees, maybe more. And then it becomes this nice molten plastic, which is malleable, and it can be pushed out of this block here and pushed into a filament, which can range in size from microns to millimeters. That's the fundamental of 3D printing. Nothing complicated behind it. That is the extrusion of filament into another material on the plate. So here we use our Ultimakers. We have many Ultimaker S5s and other types of 3D printers available to us. And this is the very standard of 3D printing. So again, this is us using FDM to 3D print a model here. You can see it doing layer by layer by layer. And I should explain as well while we're here, 3D printing is a part of additive manufacture. So additive manufacture is the addition or build-up of layer upon layer upon layer upon layer of material to build a new model. The benefit of 3D printing is wide and vast. Compared to traditional techniques and traditional methods, you can do a lot more complex internal geometries. You get a lot less waste, and it's much more flexible and it's much more open to the general public. Whereas traditional methods can be but they're highly skilled technicians who do the work, and it can be very costly and timely, especially on equipment and setup. So there's the benefit of 3D printing. Anyone can do it. So more examples of 3D printing. Here we actually have a a project that we'll be talking about very soon. You can probably tell what they all are. And these are actually printed out of plastic, but this isn't PLA. This is another type of plastic. This one's called TPU. It's a very flexible material. It has many properties, but the one we went for is flexible. So if you're coming to us looking to 3D print, you want a material to 3D print in. Maybe it's PLA. You just want the cheapest method or the cheapest material to print with to look at a design, to feel it in your hands and to actually take it to funders and prove that your design exists. But maybe you want a smarter material that has other properties. So maybe you want a 3D printed material that is waterproof, so it doesn't take up water. Maybe you want one that is flexible. So if you squeezed it, it would contract and then come back to its shape. Maybe it's elastic. There's all types of applications that suit each material type. Out there, there is conductive filaments as well. So if you needed a component to go into a system that could conduct electricity, it is out there. It is possible to 3D print, and we can do that at the AIC. It's possible to also do antimicrobial. Filaments out there have antimicrobial properties, and we've actually used some to 3D print our own door handles that you can see on screen here. So some of these are printed out of antimicrobial filament, so that when you open your door with your door hook, you can reuse it safely, and you know that you don't have to wash it every time. But the added benefit is it's also dishwashable. So if you did want to, you could chuck it in the dishwasher and know you'll get it out. You can also do other materials. So there's a huge range. But another one is high mechanical resistance. So ones with a lot of mechanical strength that don't break easily. A lot of these are for engineering applications, and we do work on them as well. So the material properties is wide. So maybe there's more as well. So here we have our Automaker again. Maybe you could use it to 3D print impossible shapes. So shapes that aren't usually printable or moldable or castable. Maybe they've got this intricate internal structure. You can achieve this by actually 3D printing with dissolvable supports. So here at the AIC, we use PVA as our dissolvable support. So you print both your PLA and PVA at the same time. And then once you're done, we can just wash away the PVA and you're left with your incredible impossible shape. We can also do easily removable supports. This is very easy with PLA, but also other materials that can just strip away and leave you with your nice finished product. And a lot of these materials we use as well are easy to source. They're very commercially available. And I'll get on to other types of materials that might be bespoke to you. And we can research with you how to get that material or how to make that material. So there's a lot of options available for plastic and plastic 3D printing. So I've gone through FDM. So this is the fused deposition modeling of the material going down into the heating blocks and being extruded. On here as well, I've got acronyms or shortened names of other types of plastic. If you're in the 3D printing world, you'll know these plastics. So we've got PLA, TPU, PETG, polypropylene, PEEK, and ABS. So again, polypropylene is the polylactic acid. That is the most common one you can ever find, derived from cornstarch in most cases, and is the most widely used. TPU, this is the flexible one. This is the one that will give you all these lovely flexible properties that we've actually used on a few projects to give us the squeeze, to give us great properties. PETG, so we use this instead of PLA when we need something that can be machine washed, that can go in the washing machine, that can be washed constantly and not degrade. We use polypropylene. Polypropylene is in all sorts of things. You get it in your plastic bottles. I'll show you later what we do with our bottle tops, which are polypropylene as well. And we also do work with engineering plastics, such as PEEK. And we also can utilize ABS as well. If you'd like to learn more about these materials, I would strongly suggest you just Google search. There's loads out there on all these materials, and they can tell you more than I can in this short webinar. So I think next we're going to go on to another technique. So here is our 3D printers in InventX. So this is our 3D printing cabinet full of all our 3D printers in front of us. You can see our Ultimakers. We've got the composite 3D printer and the metal 3D printer. We'll talk about the metal 3D printer in our third webinar series, but today I just want to also introduce our composite 3D printer. So this is the fused fiber filament, FFF is what we call it. So how is it different? It's only a bit different. So in this example, I've taken it and simplified it a bit, but what you do is put your thermoplastic filament through the same nozzle, and you insert through a different nozzle the filament. So that filament gets laid into the thermoplastic on each layer. So here is our filament extruder. This is our Mark Forged equipment, and it can do a shorter variety of materials. So it can do nylon-based materials, and it can also do a nylon with embedded carbon fiber in it. So little strands of carbon fiber, and these strands of carbon fiber can increase the mechanical strength of the plastic immensely. And then that fiber that we were talking about that runs through the thermoplastic, that can also be added, and that can be carbon fiber, it can be Kevlar, or it could also be fiberglass. So you're getting very, very strong components, or very, very chemically resistant components as well. So there's a lot of applications ready for that. So here we have our plastic again, and I think this is time for a poll actually. So we're going to ask you just a few questions just to see how everything's going. So what experience do you have in FDM? Do you have none? Do you have little? Do you have a lot? So just please vote for us. And then which technology has most interested you? So on here I've mentioned FDM, FFF, but also direct write, which I will get onto later. But the principles of direct write is the same as FDM, but without heat. We will get onto that. But if you know it, put it down. I think our next topic as well that will be coming up straight after this is we're going to go looking at recycling as well. So how to, or what you do with your recycled plastic or your waste plastic.
I've just had a couple of questions come through. What is the most complex part you've been able to print with the Ultimakers?
Ooh, that's a very good question. Most complex part. So we've done before, we've actually done lung shapes or lung components that did flex like a lung. That was very complex because you had to get the right anatomy. And that was Jordan who drew the CAD and did the 3D printing as well. What's the most complex? Moving components is a very complex one. So if you can see my screen as well, I'll be holding up a component. So it's got multiple parts in it. So it's got different materials as well and all different components. That would be quite hard to 3D print, so that took a while to put together. We've done hearts, we've done spines, we've done all sorts of bizarre but also brilliant prints. So nothing's really impossible. It's just a bit difficult, is what I'd say. Yeah. Have we got the answers to the poll? Brilliant. So what experience in FDM do you have? So we have a lot of people with no experience. That's great. Thank you for joining. Hopefully I've explained FDM all right, and you understand what FDM is. I'll explain it again as well, so we'll go over it. And if you've got any questions on it, please do just ask in the Q&A. We've got a few people with a little and a few people with a lot as well. Great. Hopefully we can expand your knowledge. and give you more information. And what technology interests you? So here we've got a few people on FGM, FFF, but also direct write. Just going to move that. And so I think we can go through a bit more FFF later on if you want to, if we've got a lot more interest in that. But we'll also carry on with FDM, and I'll show you the direct write very soon. So, without further ado, we shall get on to recycling. So, recycling is taking the shredded or used filament or waste filament and shredding it into a shredded. Sorry, I was distracted by myself there, sitting in a pile of shredded filament. So this actually happened during the COVID-19 pandemic. We actually got flooded with all this waste plastic that had to be reused and reutilized, really. A lot of them are waste components. A lot of them are waste filaments as well. So we've got a few companies that send us their waste, and what we do is take that waste. You can see there's piles of it there, there's bags of it, and we put it in the shredder, and we shred it down, and then out of that we get this lovely shredded plastic material. So it's a great example here of the circular economy as well, of the whole cycle. It's not cradle to grave anymore, it's cradle to cradle. So here we put our shredded plastic, we put it into the top of our filament extruder. It heats it up and pushes it out into this lovely strand of filament here. And it gets cooled down rapidly and taken up with the rollers. And then it gets pushed onto a spool. So we have spools identical to brand new spools of filament sitting on our shelves that we do utilize for certain projects. So here we are again, shredded filament. This one's a blue, last one was a green. We've got black, all sorts of colors being extruded and then spooled onto a filament spool. So this can be done at different filament types as well, or sizes. So you can do 1.75 or 2.85. And over the pandemic as well, we actually collected over 100 kilograms of recycled plastic, which is a lot of plastic. And we've got even more as well to utilize and to go out. And there's actually initiatives out there all across the country which are now taking PLA waste and reusing it and recycling it. So I'm just going to go on to the next one. So this is an example of some. So what you could do with the filament, you can actually make your own out of recycled materials, or a waste product, or a byproduct. So we have examples of filament that we've used from coffee grounds, from PET milk bottle tops, PET bottles, or also polypropylene bottles, failed components, so any scrap components that are printed halfway and failed, or they've just got to end of life and they've made out of a reusable, recyclable material. And we also do work with expensive engineering materials as well. So you want to not waste your components if they go to waste or anything. You just want to scrap them and reuse them. We do quite a bit of work on that as well. So if you have an idea, get in touch with us, aic.aura@hold.ac.uk, and we might be able to help you out. We might be able to do a bit of work on that. We actually used all our recycled plastic to make door handles and the visors for the COVID-19 pandemic. So there's loads of applications out there. And it was a great project to do as well. So applications of 3D printing, rapid prototyping. You could do it in a day. If you had a design, you can 3D print it in the same day. You can do design iterations day after day after day and change your component, get marketing's input, get everyone's input. And there's also engineering applications that can be used for 3D printing. So again, we've gone over fused deposition modeling. We've gone over FFF, the fused fiber filament. And here we're just going to mention direct write, which is the most simplest one. What it basically is a syringe with some polymer or some plastic in there. There's no heat involved. It just gets pushed out by yourself. So imagine a syringe with some fluid in. That's the principle of direct write. And this is actually used in food 3D printing. So you can do cakes, chocolate, that sort of stuff with this technology. Loads you can do. So we're just going to go quickly through a bit of slicing. So you saw our component there, which Jordan has made in CAD, which is the same as this device that I've got in my hands. And so now we're looking at slicing it. So what slicing is taking the component that you've drawn in CAD, this beautiful design, and giving it to the 3D printer in instructions it can understand layer by layer by layer. So it's like a bread slicer. You're slicing it down into layers. So in that, you can actually change all the properties of it. You can change the sizes of it. You can change the orientation of it. There's loads of things you can do within the slicing software to change the model. So I think here as well, we're going to change the orientation. So we're going to lay it flat. And this is for the Automaker, which we use a very common software called Cura, which is the standard software. So here we're actually changing the layer height. So you can change the thickness of each layer. You can go from extra fine, so 0.06 mil, up to 0.2. You can go higher than that as well. You can go up to a mil if you wanted to. And there is some extrusion techniques that go down to 0.05. But I would say if you want to go any lower than those resolutions, we suggest other techniques, which we will go through in the second webinar, in the resins webinar. They are much more appropriate for finer resolutions. But FDM is the great one for plastics and using plastics and cheap use. So there's a whole range of settings that you can play around with in your slicing software. This is where we come in. We fiddle with all of this stuff, so you don't have to. We can make your print perfect. We can get it right. If there's anything over 45 degrees, so in an angle over 45 degrees, 3D printers generally find it difficult to 3D print. It's a thing called overhang, where it's trying to print on air, on thin air. And we can do lots of little bits and bobs, little tricks that we can do to stop that, or to get you the perfect model. So after you've done filling with all your systems and settings, you just press print, and you go straight to the 3D printer, and you end up with applications like this. So here again is our lungs, our heart. This project will be coming out very, very soon, and we're very excited to show it off. So these are done out of flexible filaments. We've gone over plastics and how to 3D print with plastics. FDM, we've gone over how FDM works. Here you can actually see a good, the two materials going in. We've gone over filament shredding. So how to take your waste products from cradle to cradle to use them again, or adding in another property. So here we have our FDM, our Automaker 3D printers, our FFF, our composite 3D printer, nylon, carbon fiber, Kevlar. And here is where we are next. So this is just an overview of what I was talking about today. So we've got today's webinar on there, 11th of May, 3D printing plastics. This Thursday, we have our next webinar, which is going to be on CAD with Jordan on the 13th of May, designed for 3D printing. So if you've enjoyed this webinar, I would say definitely tune in for the design for 3D printing. It will give a lot of insights into the world of 3D printing. And then we have the whole series on there as well. So I'm going to be hosting on every Tuesday, plastics, resin, and a metal. And then on CAD design, Jordan will be hosting design for 3D printing, product visualization, and validating design for manufacture. And then coming soon in the future, we have webinars happening in June, July, and September. So we're very excited to go with that. And one thing I forgot to do was a poll. So could I do a second poll for everyone here just before we finish? Jordan, if that's all right, yeah?
Yeah, that's fine.
Fab. So we're going to do a second poll on recycling. So what do you currently do with your 3D printed waste? So do you have 3D printed waste? What do you currently do? Do you put it in general waste? Do you put it in the recycle bin? Or do you send it off somewhere special to get it repurposed? Of course, here at the ARC, we've been collecting it and reusing it a lot. But what do you do with your waste? Or if you know an industry that works with a 3D printer, what do they do with their waste? And is it able to get recycled?
So we have a few more questions that have come through. Hello, how would I know what material would work best for my product? Is this something you would be able to advise me on?
Yes, most definitely. We can definitely advise you on that. What I'd say is get in touch with aic.aura@hull.ac.uk, and we'll be able to help you out with what material you choose to get your 3D print and the properties you desire. So we'll learn more about your project.
We've got another question. Are filaments colored with standard pigments? If so, what is the max particle size that can be printed?
Ooh, that's a good question. Thermoplastics are generally dyed or have a pigment in there. So the blue, the yellow, the red. I'm not sure on the particular size, but it will be microns because they don't affect too badly the 3D printing filament at this resolution. So this is one reason why you can't go down to small resolutions, is because of the pigments in there. And I could go off on a tangent on this topic very easily. So if you want to actually learn more on that, I'd suggest getting in touch with aic.aura@hull.ac.uk and we can have a chat about that. But most of the pigments that go into 3D printing plastics are microns, such as titanium dioxide, which would be in the micron level. So have we got any more questions?
That's it for now, I think.
Brilliant.
Yep.
Okay, so a quick call to action from us as well. If you have any 3D printing that you would like doing, any CAD, want to learn more or how it can help your business, get in touch with us, please, at aic.aura@hull.ac.uk. Again, we've got other webinars coming up on plastics, resin, and metal, and then the whole computer-aided design bundle as well. So we've got some results from the poll as well. What do you currently do with your 3D printing waste? Everyone currently, or most people, put it in general waste or recycling bin. So maybe we need some clarity over what you actually do with PLA. Can it actually go in the recycling bin? Or does it just end up in general landfill? And that's one thing we need to check with the councils, what they actually do with PLA. Yes, it does have a recycling tag on it, but does it actually go into recycling? That is another question. And then many put it in the general waste, and a few people send it off to get specially processed. Again, there's initiatives happening all over the country where you can send in your 3D printing waste and get it recycled. So yeah, any more questions, Jordan? Brilliant. Okay, so with that then, it's dead on 12. So I will say thank you very much for listening and joining us on this webinar today. For more information, please find us at the website aura-innovation.co.uk and follow us on Twitter at Aura Innovation, or get in touch with us at aic.aura@hull.ac.uk. We would love to hear from you and how we can help your business. Thank you.
Thank you.